All right, so today we're going to be doing 4.4 notes. You'll watch this video, and then when you're done, then you'll be able to just work on the homework, and you might even be able to finish it during class today. So with 4.4, there's a little bit of a review and then some new things too. The first part is a little review. So you're going to have situations where you're going to need to draw a triangle, and it's really important that you get the triangle in the correct quadrant. So remember this down here. In the first quadrant, everything is positive. All are positive, A for all. In the second quadrant, S for sine. Sine is positive, and its reciprocal cosecant is positive, but then everything else is negative. In the third quadrant, tangent is positive, and its reciprocal cotangent, but everything else is negative. And then in the fourth quadrant, cosine is positive, and its reciprocal secant, but then everything else is negative. When you draw a triangle, you got to make sure that theta is always next to the origin and that the right angle is always on the x-axis. So an example of what not to do would be to draw a triangle like that. That would not be correct because that has a right angle on the y-axis. We don't want that. The right angle has to be on the x-axis. So it would have to look maybe something like this, right angle up on the x-axis. And then theta has to be next to the origin. It's not down here. It has to be up here next to the origin. The origin is 0, 0. Okay? The hypotenuse will always be a positive length. It will never be negative. If you have a length that's pointing down, like this one, then it should have a negative value. If you have a side length that's pointing to the left, so like this side length is pointing to the left, that should have a negative value. Okay? So just be careful about what quadrant you're in, and then I think everything else should be pretty smooth sailing. So let's go to the next page. So in this problem, they're giving you a point, 5, negative 12, and they're telling you that that point is on the terminal side of theta. So 1, 2, 3, 4, 5. Okay, so 5, negative 12 would be right there. It is on the terminal side, meaning, like if I drew this in standard position, it would be that angle all the way there. But we're going to make a triangle out of it. And remember, like I said, in order to make a triangle, it has to have a right angle on the x-axis. So I'm not going to connect it this way. I'm going to connect it up this way. And there's my right angle. So I've got a triangle, and I have some side lengths that I actually know. I had to go to the right 5, and I had to go down 12 to get to this point. Since I'm going down 12, I have to make it a negative 12. And then the angle that I'm talking about will be next to the origin, right there. So right now, I have the opposite side of the angle and I have the adjacent side of the angle. I need to figure out the hypotenuse. So you might recognize that it's a 5, 12, 13 triangle. 5, 12, 13 triangles are common right triangles. But let's say you didn't know that, so you did Pythagorean theorem. 5 squared plus negative 12 squared equals the hypotenuse squared. You could do it that way as well. So 25 plus 144. Okay, and then you're going to get 169. And when you take the square root of 169, you get 13. So our hypotenuse is 13. Now, technically when you take a square root, it's supposed to be plus or minus, but I said on the first page that the hypotenuse is always positive, so that's why we're using positive 13. Okay, so sine. Sine is opposite over hypotenuse. So opposite of our angle is negative 12, and the hypotenuse is 13. So that's your answer. Tangent is opposite over adjacent, so that would be negative 12 over 5. Done. It's very easy once you get the picture drawn. You could find all of the trig functions now that you know this picture. Okay? In this problem, we're told that tangent theta equals negative 5/4 and that cosine is greater than 0. Don't ignore this. This is there for a reason. It's going to help you to figure out what quadrant you should be in. So what quadrant or quadrants do you get cosine values that are greater than 0, cosine values that are positive? So remember this little thing. What quadrants is cosine positive? Well, cosine is positive in quadrant 1 and cosine is positive in quadrant 4. Okay, well, then take a look at this. Tangent is negative. It's a negative 5/4. Where is tangent negative? Well, tangent would be negative here or here because tangent's positive in the first quadrant and it's positive in the third quadrant. So tangent's negative in those two quadrants. So then look at which quadrant both of those conditions are met in. So both conditions are met down here in the fourth quadrant. So you have to draw a right triangle in the fourth quadrant. Make sure that the right angle is by the x-axis and theta is by the origin. And then fill some stuff in. You know tangent is negative 5/4. So tangent is opposite over adjacent. Okay, so opposite would be the 5 and adjacent would be the 4. Now we need to figure out which one is the negative. Because if I have a negative fraction, it's either the top that's negative or it's the bottom that's negative. But it's not both. If both of them were negative, I'll do it over here. If both of them are negative, then you end up with a positive 5/4. So we have to decide, is the negative on the 5 or is the negative on the 4? Well, look at what direction they're going in. 4 is going to the right, 5 is going down. Since 5 is going down, that's the one that's negative. Okay, then you probably need to find the hypotenuse in order to answer the questions. So let's do Pythagorean theorem. 4 squared plus negative 5 squared equals c squared. So 16 plus 25 equals c squared. Okay, figure out, keep going. 16 plus 25, what do we get? 41. So the square root of 41 equals the hypotenuse. Now, I would try to simplify that if it could, but the square root of 41 doesn't simplify any farther. So then now let's answer the question. Sine is opposite over hypotenuse. So opposite is negative 5. The hypotenuse is square root of 41. But you don't ever want to leave a radical in the denominator, so you have to fix that. Multiply by radical 41 on top and bottom. And that's your answer. Secant. Secant's the reciprocal of cosine. So cosine of theta is adjacent over hypotenuse. So adjacent would be 4. Hypotenuse would be the square root of 41. But we want secant. Secant is the reciprocal of cosine. So just flip this and you're going to get square root of 41 on the top and 4 on the bottom. That's your answer for secant. Okay? In this problem, we are given some slightly different information. We're given cosecant, and then we're told this right here. What's that all about? Well, on a graph, here's pi over 2, and here's 3 pi over 2, like on your unit circle. We're supposed to be between those two. So, you know how everything goes counterclockwise? So that means we're between the two. So we're in quadrant 2 or quadrant 3. And now we have to make a decision. Which one is it? So look at this information. Cosecant. Cosecant is a positive value. So which quadrant do we get cosecant positive? Remember, cosecant is the reciprocal of sine. So if cosecant is positive, then sine's also positive. And sine's positive in these two quadrants. So it's got to be in the second quadrant then, because that's where everything overlaps. The blue and the red overlap. So if I draw a triangle in the second quadrant, my given information is cosecant is radical 2. Well, I could put that over 1 if that helps. And maybe just knowing that cosecant is the reciprocal of sine, so therefore sine would be 1 over radical 2. That might help. And we know sine is opposite over hypotenuse. So I'm going to fill in that information on my triangle over here. The opposite side is 1, and the hypotenuse is radical 2. And then you're going to want to find the missing side here. So let's do Pythagorean theorem. Now be careful with Pythagorean theorem because remember that the c is the hypotenuse. So a squared plus 1 squared will equal our hypotenuse squared. So that means a squared plus 1 equals 2. So a squared equals 1. Hang on a second. Did I make a mistake? I don't think so. Yeah, we're good. Okay, so then a equals the square root of 1, which is 1. Okay. All right. So, oh, wait a minute though. Be careful. I almost missed something. See if you can figure it out. Okay, now technically when you take a square root, technically it should be a plus or a minus, right? So I have to know, should this be a 1 or should it be a negative 1? It's pertaining to this side right here, which is pointing to the left. So it needs to be a negative 1. Whoa, watch out for that, okay? It's got to be a negative 1. And again, it's got to be a negative 1 because it's pointing to the left. See, now this is where people usually make mistakes, like on quizzes and tests, is you just are rushing through, just like I did, and you're not really thinking and you're not paying attention to the little details. If it's pointing to the left, you've got to have a negative, okay? And if you've missed that, you're going to get all the stuff wrong because all your signs will be wrong. Okay, so it says find the values of the 6 trig functions. So technically we already found sine, although I would clean that up and I would say radical 2 over 2 for sine. And then cosine would be adjacent over hypotenuse, so that would be 1 over radical 2 as well. So we'd clean that up and that'd be radical 2 over 2. Tangent of theta would be opposite over adjacent, so that would be 1 over negative 1, which is negative 1. And then we could find all the reciprocal functions. So if we did Cosecant, oh, that was already given, wasn't it? Cosecant is the reciprocal of sine, so you would get radical 2, but again, that was given. Secant is the reciprocal of cosine, so let's flip cosine. Now we could either flip this one, and we'd have a 2 on the top and a radical 2 on the bottom, but then we'd have to fix that radical 2 on the bottom. I would just flip this one right here, because then you're going to have radical 2 on the top, and you're going to have a 1 on the bottom, which is just radical 2. And then cotangent of theta, we flip tangent. So that would be a negative 1 over 1, which is negative 1. Okay? So that is that whole problem. All right. Okay, this one. Find the values of the 6 trig functions. So again, we have to figure out what quadrant to put it in. So this is saying tangent has to be positive. Well, tangent is positive in the first quadrant and in the third quadrant. That's where tangent's positive. Cosine is negative. Where's cosine negative? Cosine's negative here and here. So the overlap is in the third quadrant. So you have to build your triangle in the third quadrant and then fill in the appropriate information. Cosine is adjacent over hypotenuse. So the adjacent side is the 4, the hypotenuse is the 5. Which one of them is negative? Because it's a negative 4/5. Well, the 4 is pointing to the left, so that's the one that's the negative. Okay, then find your missing side. So again, Pythagorean theorem, negative 4 squared plus our missing side squared equals our hypotenuse squared. So b squared is going to equal 9. Now be careful, just like that last problem. Should my answer be a 3 or should it be a negative 3? Well, look at what it's doing. It's pointing down, so that needs to be a negative 3. Okay, so watch out for that. Again, that's something that you might miss, is the fact that it's pointing down, so it's got to be a negative. So now you'll be able to find all your trig functions. So I don't know if we need to go through all of them, but sine would be opposite over hypotenuse, so you'd get a negative 3/5, and so on. So you'd be able to keep going now that you've got your triangle. I think you'd be okay if I skipped that. This problem, again, it's got a little bit of a twist to it. They're giving us an equation this time. They're telling us that the terminal side of B lies on that line in quadrant 2. So keep that in mind. If we were going to graph this line, I would probably want it to be in slope-intercept form. So that means I'd need the y all by itself. So if you subtract the 4x and then divide it by 3, that would be our equation to graph. Now there's no y-intercept, so it starts at the origin. And then it has a slope of negative 4/3. So I would go down 4 over 3. Or I could go up 4 over this way 3. Okay, so that's my line. But the problem specifically said that we need to be in quadrant 2. So I only want to focus on this right there. So I'm going to make a triangle out of that. Okay, so there's my right angle, there's my theta, and what is the information I know? Well, I know that I had to go to the left 3, so that would be a negative 3, and I had to go up 4. So find your missing side. You recognize 3, 4, 5 triangles, so the hypotenuse is 5. And then there you go. You'll be able to find all your trig functions. Sine would equal opposite over hypotenuse. Cosecant is the reciprocal of that, so flip it. You're going to get 5/4. Cosine is adjacent over hypotenuse, so negative 3/5. Secant is the reciprocal of cosine, so flip it and you get negative 5/3. Tangent is opposite over adjacent. Cotangent is the reciprocal of that, so just flip it and you get negative 3/4. So the problem is really fast after you get the picture drawn, but the most important thing is to get the picture drawn correctly. Okay? Quadrant angles. That's just a fancy name for angles that are on the axis. So what they're talking about is like 0 to pi would be right here. Up here, this is pi over 2. Over here is pi. And down here is 3 pi over 2. Those are quadrant angles. And that's it. I mean, there's really nothing crazy about it. So just remember, you know, like if you're at pi, that coordinate is -1, 0. And just remember that -1 is cosine and 0 is sine. So for example, if they want secant of pi, secant is the reciprocal of cosine. So just flip cosine. So flip -1 over 1. You're going to get 1 over -1, which is still -1. Sine of 6 pi, I know that might seem a little weird, like what's up with 6 pi? Think of it this way. Here's 1 pi, there's 2 pi, here's 3 pi, 4 pi, 5 pi, 6 pi. So 6 pi ends up right there. The coordinates at that point is 1, 0. So if I want sine, it's just 0. Okay, so I mean all of these are quadrant angles. 3 pi over 2 is down here. You should be able to figure out cotangent. -7 pi over 2, if you don't like the look of that, just find a coterminal angle. I would add 2 pi. And remember, you need a common denominator. So that would be -7 pi over 2 plus 4 pi over 2. So you'd get a -3 pi over 2. And again, if you don't like that, add 2 pi again. So -3 pi over 2 plus 4 pi over 2, you're going to get pi over 2. So you're really up here. What's tangent up there? So that point is the point 0, 1. And tangent is sine over cosine. So you get a 0 on the bottom, which is undefined. Okay, moving on. Just trying to think if I want to do this page or not. Let me think. Now we're going to skip that page. Okay, reference angles. This is something new. We haven't talked about reference angles yet. Reference angles, it says it's the angle between the terminal side of an angle and the x-axis. So, let me get my color. So the original angle is the green angle here. This is the terminal side. This red side is the terminal side. So a reference angle will be the angle between this terminal side and the x-axis. Basically, it's the shortest way to getting to the x-axis. So, for example, let's say that theta is 300 degrees. Let's go with that. If we want to find our reference angle, which is theta with a little like apostrophe, how would I get that? Well, what would be this remaining part? If the whole circle is 360 degrees and I've already gone 300, then that means that this little chunk right here is 60. So what you're doing essentially is you're taking 360 and you're subtracting off the angle that you were given. So in this particular case, we're going to get 60 degrees. I'm just going to color code it nice. Okay, so if you like formulas, technically here's your formula then. And this formula works when you're in the fourth quadrant. That's Roman numeral 4. But you don't really need a formula. If you got a picture, you can basically figure out that, oh, I needed to subtract the green stuff from 360 to get the blue stuff. Okay, but if you like formulas, there you go. Here is when you're in quadrant 3. I don't know why we use Roman numerals when we're talking about quadrants, but we do. So in quadrant 3, our original angle is the green angle. The reference angle will be the quickest way back to the x-axis. So how do we figure out the blue when the green goes all the way to there? Well, the blue is this stuff, not the top green stuff. Well, how many degrees is this top stuff that we don't want? That top stuff that we don't want is 180 degrees. So let's just give an example. Let's say that theta in this case is 200 degrees. Okay, so all the way from here to here is 200 degrees. Well, I don't want this top stuff, 180. So if I subtract off that 180, I get the blue reference angle. So if we subtract off the 180, our blue reference angle would be 20 degrees. Okay, now again, if you like your formulas, your reference angle would equal the angle that you were given, which was 200, and then we subtracted off 180 degrees. So that would be your formula, if you want one, when you're in quadrant 3. If you're in quadrant 2, let's say our angle that we're given, let's pretend that it is 100 this time. Okay, so 100 gets you here, and then we want the quickest way to the x-axis, which would be the blue. Well, this whole thing is 180, so if we got 100 degrees so far, how many more degrees do we need to get to 180? So we know that our reference angle is going to have to be 80 degrees. And again, if you like your formulas, the way we got that reference angle was basically taking 180 and subtracting off the green stuff. So taking 180 degrees and subtracting off the original angle. So again, there's a formula if you want it, but again, you don't really need it. If you draw a picture, you'll know what quadrant you're in and it'll all make sense. You'll know, should I subtract it from 360? Should I subtract off 180 to get rid of this top stuff? Or should I subtract it from 180? Just draw a picture, you should be fine. Okay, so in the directions here, it says find the reference angle. Again, that's the theta with the little apostrophe. Okay, so if I draw 322 degrees, I'm just going to get a guesstimate. I'm thinking it would be, you know, over here somewhere. So 322 degrees would be that green angle. If I want the reference angle, I want the quickest way to the x-axis. So that blue angle would be my reference angle. How do I get it? Well, all the way around is 360 degrees. So to get that reference angle, I'm just going to take 360 and subtract off the 322. And I'll end up with 38 degrees. So that's the reference angle. Okay? 17 pi over 7. Well, you might want to find a coterminal angle with that. You might want to subtract off 2 pi just to bring it down so it's a little bit more manageable. So really we're doing 17 pi over 7 minus 14 pi over 7. So we get 3 pi over 7. Okay, now I know that's not on your unit circle, but you got to kind of just think it through. Remember, this is pi, aka 7 pi over 7. So half of that would be 3.5 pi over 7, right? So then 3 pi over 7 would be like here. Okay, so that is my original angle right there, 3 pi over 7. Okay, well, reference angle would be the from where this ends, the quickest way back to the x-axis. Well, which way is quicker, going this way to the x-axis or going this way to the x-axis? I think this way is the quickest way, the shortest way. So that angle is 3 pi over 7. That's your reference angle. Okay? Almost done. So you've had problems like this before where you have to find two angles, excuse me, two angles that satisfy this condition. So in other words, we're looking for angles where you get negative radical 3 over 2 in the sine spot. So when you're looking on your unit circle, the sine spot is the second one. So we're looking for the angles where you get a negative radical 3 over 2 in the sine spot. So where does that happen? Look on your unit circle sheet. Where do you get negative radical 3 over 2 in the sine position? Look on your unit circle sheet. That happens at, I believe, 4 pi over 3 and 5 pi over 3. Hopefully I did that right. Check your unit circle to make sure I did that right. For this one down here, cosecant theta equals 2. If that kind of wigs you out, I would think of it as the reciprocal function. So sine is the reciprocal of cosecant. So the reciprocal of 2 is 1/2. I think that would be easier to look on your unit circle for a 1/2 in the sines position. So look on your unit circle for all the angles where you get a 1/2 in the sine position. And I believe that that would happen at pi over 6 and at 5 pi over 6. Okay, last page. This page, make sure that you understand this stuff because you're going to be using your calculator, but the problem is your calculator is only going to give you one out of the two answers. So you have to be extra clever and figure out what the second answer is. So I'm going to try to walk you through that. In order to get the angle in your calculator, to get the angle alone, it's like we have to get rid of this cosine. And the way to do that is to use the inverse cosine, which looks like a cosine with a little -1. And look for that on your calculator. See if I can get my calculator to come up here. You'd try it, and let's see if we can get it. Okay, so on the calculator, if you go to the trig, there's the cosine with the little -1. Press that, and then type in -0.6281. Okay. So 128.91, this is in degrees, 128.91 degrees. Okay, that's one of the answers, but we have to find the second answer. Okay, it's going to help if you draw a picture. About 128 degrees, draw, I don't know, maybe like right about here. Okay, now, do you see how the value of cosine was negative? What other quadrant would you get a negative value of cosine? Okay, so what other quadrant do we get a negative cosine? Remember your little picture here. So cosine is negative in the second quadrant and in the third quadrant. So it would also be negative here. It's going to be a nice perfect reflection over the x-axis. So we have to figure out what is that angle right there. Okay, so see if you can figure out how to find that angle. Now, just remember, you went that direction and got a positive 128.91. One way to figure this out would be to go the other direction the same amount, right? If I went this direction, it would be a negative 128.91 degrees. Now let's answer that as a positive angle though. So in order to give it as a positive angle, add 360 degrees, and you're going to get 231.09 degrees. That would be if I went like that. That angle would be 231.09 degrees. Okay, so again, you had to figure out what other quadrant would cosine be negative in. And then you just kind of have to use some logic to figure out what the other angle is, because your calculator only gives you one of them. Okay, this is the last problem, so let's do it on the calculator. So actually beforehand, in order to get b alone, beta alone, I'm going to have to do the inverse tangent of 1.4553. Okay, so get your calculator. go to the trig, inverse tangent, and then type in 1.4553. Okay, hit enter, and you get 55.51 degrees. So on our picture, if I was going to draw about where 55.51 degrees is, I'll say it's right here. Okay, now again, that's just one of the answers. We have to figure out where the other angle would be. So what other quadrant do you get a positive for tangent? Okay, so tangent is also positive down here in the third quadrant. So it's going to be a nice perfect reflection down here. Imagine this is a nice straight line. Mine's definitely not straight, but just imagine it straight. How would you figure out this angle? Okay, so remember, I had to go this direction, 55.51 degrees, and I want to go that much more. How much more am I adding on? How much more is this green stuff? That green stuff is 180 more degrees. So take the 55.51 and add 180 degrees, and you're going to get 235.51. Does that sound right? Okay. So again, with these, your calculator will only give you one answer. You have to draw a picture and use your brain and figure out the second answer. There's no other way around it. Okay, so that's 4.4. You should have quite a bit of time now to work on the homework and potentially get it done during class. Okay, have a good day, guys. See ya.